Hello, everyone. Welcome to Backyard Musings. Good morning. Broadcast from Apple Valley, California. I'm Steve.
I'm Scott.
We are the Science and Technology channel. We talk about science, anything technology. Could be health, could be earth science, could be astronomy, any kind of science. We like bringing it to you. And today we're going to be talking about the moon. In a groundbreaking effort to enhance lunar exploration, NASA has launched the Blue Ghost Mission 1, featuring a suite of scientific investigations and technology demonstrations aboard a Firefly Aerospace spacecraft. This mission, part of NASA's Artemis campaign, aims to test new technologies on the moon's surface, including lunar drilling and dust mitigation methods, which will pave the way for future manned missions and extended lunar stays. The successful collaboration between NASA, Firefly, and SpaceX marks a significant milestone in publishing a sustainable human presence on the moon and beyond. Would you like to know more?
Yeah, let's get back to the moon, right? We need to do that.
That could be a launching pad to get to Mars or Europa or Io.
Yeah, wherever. Yeah, exactly. NASA's launched a suite of scientific investigations and technology demonstrations aboard a commercial spacecraft destined for the moon. These projects aim to study the moon's environment and test innovative technologies to help future astronauts land safely on the lunar surface as part of the Artemis campaign. Blue Ghost Mission 1, Firefly's Aerospace's first commercial lunar payload services, flight from NASA lifted off at 1:11 a.m. Eastern Standard Time aboard a SpaceX Falcon 9 rocket from Launch Complex 39A at NASA's Kennedy Space Center in Florida. The mission is scheduled to land on the moon on Sunday, March 2nd. So just a little, like less than a couple months away. So that's cool.
Yeah, it's going to land. Well, it has to take off and come back, I think. I don't think they're just going to leave it there. So land on the moon, do its thing, come back. That's astounding, and it's amazing. And it's not it's not a manned mission. It's all remote control. It's pretty cool.
Yeah.
Really cool.
Which, I mean, that's kind of that's what's been happening with the main bodies of these rockets that SpaceX has been launching, right? They've been bringing them back.
Colombo.
Yeah, bringing them back and landing them right on the launching pad. So that's really cool.
Yeah, definitely. Once on the moon, NASA will test and demonstrate lunar drilling technology, regolith, lunar rocks and soil sample collection capabilities, global navigation satellite system abilities, radiation-tolerant computing, and lunar dust mitigation methods. The data captured could also benefit humans on Earth by providing insights into how space, weather, and other cosmic forces impact our home planet. So as far as space weather, I think that would be like radiation coming off the... I don't think we're talking about sun and rain or rain and wind. We're talking about radiation, I think, and comets and stuff.
Yeah, well, again, I don't know if they have any of those kind of weather patterns, right? I mean, we haven't been on the moon enough. We've been on there enough times, but we haven't spent a lot of time there while we're there.
Radiation. Yeah, they don't have an atmosphere that blocks the radiation like we do, so it's a little bit more severe on that moon.
Right. As part of NASA's modern lunar exploration activities, CLPS, or CLIPS, I'm going to call it, deliveries to the moon will help humanity better understand planetary processes and evolution, search for water and other resources, and support long-term sustainable human exploration of the moon in preparation for the first human mission to Mars. Firefly's Blue Ghost lander is set to touch down near Mons Latrell. Is that how you pronounce that? Latrell?
Yeah.
A volcanic feature within Mare Crisium, a basin over 300 miles wide, located on the northeastern part of the moon's near side. This mission will collect valuable scientific data about the moon, contributing to our understanding of Earth's closest celestial neighbor and laying the groundwork for Artemis astronauts to explore the lunar surface later this decade. That is exciting.
That is exciting. So there are 10 NASA payloads flying on the flight, and Scott and I are going to go back and forth between each one. The first one, lunar instrumentation for subsurface thermal exploration with rapidity. They call it LISTER. Will characterize heat flow from the interior of the moon by measuring the thermal gradient and conductivity of the lunar subsurface. It will take several measurements to about a 10-foot final depth using pneumatic drilling technology with a custom heat flow needle instrument at its tip. Lead organization is Texas Tech University.
That just sounds really cool.
Yeah.
And hopefully, I mean, we'll be able to watch this in live time. So that's cool.
Oh yeah, there'll be cameras on it. So yeah.
The Lunar Planet VAC, or LPV, is designed to collect regolith samples from the lunar surface using a burst of compressed gas to drive the regolith into a sample chamber for collection and analysis by various instruments. Additional instrumentation will then transmit the results back to Earth. Lead organization on that one is Honeybee Robotics.
I personally would prefer like a hydraulic excavator, like an arm to scoop it and put it in, but they're going to use, they're going to blow the stuff into a box, I guess.
They've had some of those on some of the prior lunar landers before Apollo, before the Apollo project. I think one of them was called the Surveyor project, if my mind does not fail me. And that had one of those little backhoe type deals on it.
Cool. Okay, so the next one is Next Generation Lunar Retro Reflector, NGLR, serves as a target for lasers on Earth to precisely measure the distance between Earth and the moon. Hey, we need to know that precise measurement. The retro reflector that will fly on this mission could also collect data to understand various aspects of the lunar interior and address fundamental physics questions. Lead organization, University of Maryland.
Okay, well, they're spreading it around.
Yeah.
Regolith Adherence Characterization, or RAC, will determine how lunar regolith sticks to a range of materials exposed to the moon's environment throughout the lunar day. The RAC instrument will measure accumulation rates of lunar regolith on the surfaces of several materials, including solar cells, optical systems, coatings, and sensors through imaging to determine their ability to repel or shed lunar dust. The data captured will allow the industry to test, improve, and protect spacecraft, spacesuits, and inhabitants from abrasive regolith. Lead organization on this is that Aegis Aerospace. I'm not familiar with them either. Yeah. So a lot of companies I'm not familiar with, but that's cool that they're all getting involved in this thing.
Yeah. Radiation tolerant computer called RAD-PC will demonstrate a computer that can recover from faults caused by ionizing radiation. Several RAD-PC prototypes have been tested aboard the International Space Station and Earth orbiting satellites, but now will demonstrate the computer's ability to withstand space radiation as it passes through Earth's radiation belts while in transit to the moon and on the lunar surface. The lead organization is Montana State University. Go MSU.
Yeah. Next one is Electrodynamic Dust Shield, or EDS, is an active dust mitigation technology that uses electric fields to move and prevent hazardous lunar dust accumulation on surfaces. The EDS technology is designed to lift, transport, and remove particles from surfaces with no moving parts. Multiple tests will just demonstrate the feasibility of the self-cleaning glasses and thermal radiator surfaces on the moon. In the event the surfaces do not receive dust during landing, EDS or EDS has the capability to redust itself using the same technology. Lead organization on that is NASA's Kennedy Space Center.
So this is kind of like a little robot goes out and cleans stuff, but almost like a force field, electric field to do it.
Well, it sounds like it can get dirty too.
Yeah.
Yep. So
pretty cool.
Yeah.
Lunar Environment Heliospheric X-ray Imager, LEXI, will capture a series of X-ray images to study the interaction of solar wind, and the Earth's magnetic field that drives geomagnetic disturbances and storms. Deployed and operated on the lunar surface, this instrument will provide the first global images showing the edge of Earth's magnetic field for critical insights into how space weather and other cosmic forces surrounding our planet impact it. Lead organizations are NASA's Goddard Space Flight Center, Boston University, and Johns Hopkins University.
Okay. Lunar magnetotelluric sounder, or LMS, which I'm glad for that abbreviation, will characterize the structure and composition of the moon's mantle by measuring electric and magnetic fields. This investigation will help determine the moon's temperature, structure, and thermal evolution to understand how the moon is cooled and chemically differentiated since it formed. Lead organizations on this are Southwest Research Institution.
Cool. Everybody's getting in on this. This is cool.
Yeah.
Lunar GNSS receiver equipment. The acronym is LUGRE, will demonstrate the possibility of acquiring and tracking signals from global navigation satellite system constellations, specifically GPS and Galileo, during transit to the moon, during lunar orbit, and on the lunar surface. If successful, LUGRE will be the first pathfinder for future lunar spacecraft to use existing Earth-based navigation constellations to autonomously and accurately estimate their position, velocity, and time. Lead organizations, NASA Goddard and Italian Space Agency. I love this. It's a little like a GPS thing to show where you are. Love it.
And the last one is a stereo camera for lunar plume surface studies. And they're calling this one SCALPS. And that will use stereo imaging, photogrammetry to capture the impact of a rocket plume on lunar regolith as the lander descends on the moon's surface. The high-resolution stereo images will aid in creating models to predict lunar regolith erosion, which is an important task as bigger, heavier payloads are delivered to the moon in the close proximity to each other. This instrument also flew on Intuitive Machines' first CLPS delivery. Lead organization is NASA's Langley Research Center.
I can see this as all the groundwork to put like a habitat up there where you could have 20, 30, 40 scientists working, and doing stuff, drilling, finding water, and then it just grows from there.
Yeah, what was that? What was that thing called? Was it called the biodome that they had?
Yeah, it was Arizona, wasn't it?
I think it was in Arizona.
Yeah.
It was just
they locked themselves in this biodome for a year.
Yeah, it was. I could see them going up there and erecting something like that. It's got some Star Wars-y type stuff to it, where these people are out on these planets, and there's all kinds of different environmental issues that they got to deal with. And maybe not riding around on some of those crazy animals and creatures that they did, but yeah, this is cool. Cool stuff.
Yeah. Really cool. Thanks for joining us today. We'll catch you on the next one.
Take care, everyone. Thanks.